My name is Wyatt Vick, and I'm a junior at St. Trace High School.
My name is Charlie Klein. I'm a junior at St. Trace High School, and our project is titled The Effects of Various Preservatives on Color in Fresh Pork. We chose this project because we're both in 4-H, and we take animals to the fair, and we're in FFA, which is the Future Farmers of America, and our FFA chapter hosts a sausage breakfast, which takes a hog down to the sausage, and it's done all by the students. We're both involved in that, in the processing of the meat. And another reason we chose this project is because we're both student athletes and we care about what we put into our bodies. And when we learned that the nitrites that are used to preserve the color in the pork could be potentially harmful, we decided that we would like to do some research on some possible alternatives to the preservation methods.
So in order to complete this project, we first obtained a raw pork belly from our FFA, our school's FFA. We then cut that into different samples and we treated them with 4 different chemical treatments. We used sodium nitrite, the industry standard, sodium ascorbate, an antioxidant, sodium lactate, and potassium sorbates, 2 common food additives, and we left some pieces with no treatment as controls. Then we performed 2 different tests, an objective test and a consumer evaluation, which happened once every day for 5 days in order to see how the color and appearance would change over time. The objective test uses a spectrophotometer to measure L-star, A-star, and B-star color values, and the consumer evaluation consisted of 3 members of Dr. Lydia Garcia of OSU's meat judging team, who would rate the physical appearance of the meat and how much it appealed to them.
Our problem is, out of sodium lactate, sodium nitrite, sodium ascorbate, and potassium sorbate, which one would retain the color in our pork best, and which one would have the most appeal to the customers?
So our hypothesis is that the pork treated with sodium nitrite will retain its color the longest and have the most customer appeal by the end of the 5-day period. We believe this because it's the current industry standard and it's used in almost all cured meats that are available on the market. We believe sodium ascorbate will be the next best performer, as it will also protect the color, not quite as well as nitrite we predict, but we think it will still protect the color as it's a powerful antioxidant, and it can react with oxidative species that might be present, that might oxidize the deoxymyoglobin into metmyoglobin, the less desirable form of myoglobin, before that they can get to the deoxymyoglobin. So we believe that sodium lactate and potassium sorbate will slow down the change in color, not as much as nitrite or ascorbate, but we do believe that sodium lactate and potassium sorbate will retain their favorable color longer than the control, which receives nothing. We believe that will change color the most and receive least favorable consumer ratings by the end of 5 days.
To perform our study, we'll be using a spectrophotometer, which gives you an L-star, which is white to black, a A-star, which is green to red, and a B-star, which is yellow to blue. Blue being the lowest and yellow being the highest on the B-star, green being the lowest and red being the highest on the A-star, and on the L-star, the white would be a higher number and black would be a lower number. So we hypothesized that the L-star, A-star, and B-star numbers would all go down as the meat is a lighter, more red color. So we hypothesized that the L-star, A-star, and B-star graphs would have a steady decline.
So the variables for our project are first the controls. We controlled for a lot of things, especially when it came to the meat samples. First of all, they all came from the same source. They were all cut from the same pig. It was all raw pork belly. It was all cut at the same time, same pig, so same living conditions, same type of feed. They were then cut into sample sizes that are the same size, and every single process that happened to those samples was done at the exact same time. They were all the same age at every single moment. We then controlled in our treatments by using the same volume of water for each treatment and dissolved the same mass of pure preservative into that water. We then put those into 4 identical spray bottles to spray the preservative onto the meat and control for that, keeping it the same method of spraying, the same volume of spray, the same distance away from the sample. We then controlled in our testing by using a refrigerated display case so that all of our samples were kept at the same temperature, same atmospheric composition, same lighting. We then controlled further by wrapping them all in the same type of PVC overwrap with the same methods. In our objective test, we controlled by using the same spectrophotometer for every single reading that we took throughout the whole 5-day period. And in our consumer evaluation, we controlled for outside variables by always using 3 people each day. Those 3 people would always be members of OSU's meat judging team, and they were not aware of our hypothesis or what we treated the samples with. They were simply told, judge these meat samples as individuals and judge them, bring them all to the same location when judging, so that lighting and other effects would not cause certain ones to be favored over others. Additionally, we never participated in consumer evaluation trials, as we would obviously be biased. So our independent variable in this study is the type of treatment that the samples received. Our dependent variable is objectively, for the objective test, the readings that the spectrophotometer gives, and our dependent variable for the consumer evaluations was the ratings that the consumers gave the samples.
To perform our project, we used a raw pork belly, which was cut using a knife on a cutting board in the OSU meat lab. We wore hairnets and gloves while cutting this meat. It was then wrapped using a PVC overwrap machine at the meat department at OSU. And then we would put our dissolved chemicals, sodium ascorbate, sodium lactate, sodium nitrite, and potassium sorbate into spray bottles, then spray them onto the meat before it was wrapped. And then we would store the meat in a refrigerated display case, the meat was then read using a spectrophotometer, getting the L-star, A-star, and B-star readings.
So the procedures for this project were first to attain the meat, which we got from our school's Future Farmers of America chapter. We then cut the meat into 10 identically sized pieces. We treated 2 of these pieces with each treatment. So we would have 2 pieces with sodium nitrite, 2 with sodium ascorbate, 2 with sodium lactate, 2 with potassium sorbate, and 2 with no treatment as controls. Then for the actual testing, well, in order to produce those actual solutions, what we did was we dissolved 4 grams of each pure preservative into 400 milliliters of water and sprayed it on with the spray bottles. So for the actual testing procedures, what we did was, first we did an objective test, which happened once a day for 5 days. And second, we did a consumer evaluation, which happened again once a day for 5 days. So for the objective test, what we would do is we would get the spectrophotometer and we would take 2 readings on each meat sample. We would take these readings in large areas of red muscle, and each reading would give us an L-star, A-star, and B-star reading all in one. We would record these, and in the end, we had 300 separate data points of objective readings. For the consumer evaluation, 3 members of Dr. Lyda Garcia's meat judging team would come in with a form that we designed, and they would rate each sample from 1 through 7, 1 being the best, 7 being the worst, 4 being neutral. We would then record that data, and after 5 days, we ended up with 150 separate consumer evaluations.
On our graphs, so we have the L-star, A-star, B-star, and then we have our consumer evaluation. On our L-star, you can see that there's no real trend. It goes up and down quite a bit, and the deltas on our graphs are very minimal.
So for the A-star readings, which again has A-star readings versus time, you can see from day 1 to day 5, there is not much change overall. And again, for the control being the dark blue line, there's no major differences between the control and the treated samples, and there's no major differences between the treated samples either.
Again, in our B-star rating, there's no real steady decline. There's a steady decline that can be seen in our potassium sorbate, but everything else goes up and down quite a bit and is not very good data.
So as for the consumer evaluations, there are some very clear trends and things that stand out. So first of all, for the consumer evaluation averages, which we averaged the scores that the consumer evaluators gave to each of our samples, you can clearly see that the light blue line is a huge outlier, and it initially rises very quickly. This is the potassium sorbate. And we could actually see this for ourselves. Immediately by day 2, it had very quickly gained a very dark oxidized look to it. The other aspect of this graph that stands out is the gray line, which is sodium lactate, that starts at a higher position than the rest of the lines. This is due to one of the consumer evaluators simply giving it a worse rating by day 1. And it is important to note that this rating has nothing to do with the actual treatment. It is just something that the sample started out with. So the important thing is to look at here is the net change, the change from day 1 to day 5. And it can be seen in the consumer evaluation in the consumer evaluation graph that the control actually had about twice the net change that the sodium lactate, sodium nitrate, sodium ascorbate had on average, with the obvious exception of potassium sorbate, which had a huge change.
When looking at our graphs from the spectrophotometer, we decided to do margin of error and see if it was usable data. And as it goes up and down and does not follow a clear trend, we decided we were not going to use it. We also decided this because our margins of error had large overlaps, so we decided that our data was not good enough to use.
So for the consumer evaluation averages, this data was conclusive, while the objective readings were deemed inconclusive due to our statistical analysis. We performed a similar statistical analysis on the consumer evaluation averages, calculating the standard deviations and then calculating the margins of error. So what we found from this was at alpha equaling 0.1, the average changes from day 1 to day 5 are significant enough for potassium sorbate being much worse than the control, and for the sodium ascorbate and sodium nitrite having less change. So our sodium lactate actually has, on average, the smallest change from day 1 to day 5. However, the consumer evaluation marks vary the most. So our margin of error was quite large, and it actually overlapped a very small amount with our control. But when it comes to the sodium nitrite and the sodium ascorbate, these margins of error do not overlap with the margin of error for the control. So we are able to confidently conclude that the sodium nitrite and the sodium ascorbate did cause our samples to maintain their color for longer and maintain a more appealing look for consumers when compared to no treatment.
Our research has many applications. One of our applications would be to have more honesty within the meat market. Currently, there are lots of products that are marketed as nitrite-free, which a lot of these meats and foods would be treated with a celery or other vegetable juice, which contains a nitrate, which will then break down into the nitrites, which could possibly break down into the nitrosamines within your body, which the nitrosamines are the potentially carcinogenic, the nitrosamines could potentially be carcinogenic. Another application of this would be to reduce food waste, because currently about 20% of the meat produced in the United States goes to waste and is thrown away. Much of this is due to the browning process, the oxidation in the meat. If we had a more efficient protection against the oxidation, we could have less meat being pointlessly thrown away and wasted.